this is Mike Madewell from the Technical Support Department. In this segment, we'll be learning about the flow functions of the ACC controller for both conventional and two-wire decoder system models. The ACC controller is a large-scale commercial controller that incorporates a variety of advanced features, including flow sensor capability. We will go over the importance of incorporating flow monitoring to an irrigation system. We'll cover some of the considerations that need to be taken into account when planning for the installation. We'll review certain specifications that you need to keep in mind during the installation process. We will also show you how to configure the flow sensor at the controller level, as well as how to program stations to be monitored or not monitored by the flow sensor. Finally, we will explain the process for learning flow and for setting up the overflow and underflow percentages. All ACC controllers have the ability to monitor flow, and it's relatively inexpensive to incorporate a flow sensor. One of the main reasons to install a flow sensor is to prevent geysers caused by broken lines or broken sprinklers. Another reason that flow monitoring is important is that it keeps a record of the flow value by station and/or by program. The controller keeps histories of flow totals for today versus yesterday, week to date versus last week, month to date versus last month, and year to date versus last year. You can also view these totals by controller, by program, by SSG or station group, and by station. You can see this information in your preferred units of measure, whether it's liters or gallons. To change the units of measure, turn the dial to set current date and time and scroll to the bottom using the down arrow button and change from English to metric. If you choose metric, instead of seeing gallons per minute, you will see liters per minute. Prior to installing the flow sensor, you need to determine if you'll be using an ACC conventional or an ACC two-wire decoder system. If you are going to use the controller as a conventional system, the flow sensor needs to be connected directly to the controller. However, if you are going to use a decoder system, you will have the option of connecting the flow sensor either directly to the controller or through a sensor decoder, also known as ICD-SEN. The location of the sensor might be the determining factor to decide how to connect the sensor. If the sensor will be located near the controller, then you can simply connect it directly to the controller, even though you are using a decoder system. On the other hand, if you plan to install the sensor far away from the controller, you might benefit from connecting it via the two-wire path using a sensor decoder. Another consideration is the location of the flow sensor in the main line. It is recommended that the flow sensor is installed on the main line after a normally closed master valve, leaving at least 10 times the pipe diameter of straight pipe upstream of the sensor body inlet and at least 5 times the pipe diameter in length of straight pipe downstream of the sensor body outlet. This means within the described area of the pipe there can be no 90s, T's, or bell housing couplings, only straight smooth pipe to avoid turbulence. For example, if the diameter of the pipe is 2 inches, then you must have at least 20 inches of straight pipe upstream of the sensor and 10 inches downstream of the sensor. Hunter makes the FlowSync flow sensor to be used in conjunction with the FCT sensor body. They are sold separately, and you'll want to pick the right size sensor body to be used with your size of mainline. For example, if you are using a 2-inch Schedule 40 sensor body, then you would choose FCT 200. Please refer to the Hunter catalog or the flow sensor owner's manual to find the most appropriate sensor body model to use. When installing a Hunter FlowSync sensor, remember to observe polarity. The sensor has 2 wires, one red and one black. When running wires from the flow sensor to the controller, even though you will be extending the wires, be sure to observe which wire is coming from the red wire and connect it to the red terminal marked flow. Likewise, be sure to connect the extended wire coming from the black wire to the black terminal at the controller. If you plan to connect your Hunter FlowSync flow sensor through a sensor decoder, the same concept applies with respect to polarity. Also, be sure to program your sensor decoder at the controller before you install it in the field. To program a sensor decoder, we'll use the red and blue wires and insert them into the 2 programming port holes on the decoder module. It does not matter which one goes where. Turn the dial to Advanced Features, Select Decoder Functions and hit plus. And with Program a Decoder flashing, use the plus button again. The controller will recognize that it is a sensor decoder, and it will ask you for the address number that you wish to assign to the decoder. Note that these numbers have nothing to do with the station addresses 1 through 5 because sensor addresses are separate from station addresses. Finally, press the Programs button to send the information to the decoder. Programming complete. The sensor decoder has 2 ports, A and B. Port B is used to connect click-type sensors such as a rain click sensor. Port A can also be used to connect a rain sensor, but this is the only port that allows you to connect a flow sensor. When you connect a flow sensor through a sensor decoder, be sure to use the looped purple wires and that you observe polarity. As you can see, the negative side is on the front. Therefore, when you cut the looped wire, make sure to connect the black or negative wire coming from the flow sensor to the negative or front purple wire coming from the sensor decoder. Likewise, connect the red or positive wire from the sensor to the back of the positive purple wire from the decoder. So remember, whether you're hooking up your Hunter FlowSync flow sensor directly to the controller or you're hooking it up via a decoder through the 2-wire path, you only want to utilize 1 flow sensor per controller. So once the flow sensor is physically installed in the field, the next step is to configure the sensor in the controller. With the dial in the run position, hold down the blue information button and turn the dial to set flow monitoring. Release the blue button to unlock the flow operation menu. Use the down arrow button to select flow sensor and use the plus to access it. Here is where we'll be choosing which flow sensor size it is we have installed in the field. Using the plus button, we can scroll through the Hunter flow sensor sizes as they're already in the face pack. And at the end of the line, you can go to Other if you have a Badger Meter or Data Industrial IR220 series installed in the field. You will need to input the manufacturer's specifications for K-factor and offset manually. The other selection, using the down arrow, brings you to the location. Here it says Controller, and we'll need to change that with the plus button to ADM. That tells the controller to look for the flow information on the 2-wire path as opposed to being hardwired directly to the controller. So if you have the flow sensor connected to a decoder on the 2-wire path, you have to make sure that the flow sensor is mapped as far as his location to ADM or decoder in the controller. To set up a sensor decoder with a flow sensor, turn the dial to Advanced Features, use the down arrow to go to Decoder Functions and select Plus. From there, the second line says Sensor Decoder Setup. Use the plus to access it. And the first line item shows flow. The address you can choose is 1 through 5, and in our case, we've chosen address 1. So we'll use the plus to go to 1, and with flow, it will always show port A. So now that the sensor is actually installed in the field, and we have it mapped here in the face pack, let's take a look at how the face pack displays actual flow. So let's turn on a station. Move the dial to manual operation. With program flashing, use minus to go to 1 station. It shows station 1 with 5 minutes. And turn the dial back to the run position. When the dial is in the run position and stations are running, if you press and hold the information button, you'll be able to see a snapshot of the current flow. To see real-time flow, turn the dial to Advanced Features and select Utility Functions. And choose View Sensor Status. This is the amount of water currently passing through the flow sensor. The flow value that you can see here accounts for everything that causes the flow sensor paddle to spin, whether it is irrigation activated by the controller, an open hose bib, or a broken pipe. Now let's turn on a station. To see real-time flow, turn the dial to Advanced Features and select Utility Functions and View Sensor Status. Similarly, when the controller records the flow totals, which you can access by turning the dial to Data History and selecting Flow Totals, the values that you see represent the total measured flow. You can also view flow values by individual programs, simultaneous station groups, or individual stations. Each of these categories also allows you to track flow values for different periods. So note that at this point in time, we have not learned flow for any of the stations. So the controller is not going to respond to any flow irregularities because it has nothing to base that flow against. So it's crucial to learn flow so the controller can perform correct flow responses. In order for the flow of all the stations to be learned, all zones must have minutes programmed in the program. Any station that has 0 minutes programmed in will not be learned during the flow process. Once you have verified that the desired stations have run times, turn the dial back to the run position and press the Copy Learn button. The display will ask you if you want the learning process to begin. Press the plus button to confirm. The controller will start learning the flow for each one of the stations. Each station can take from 35 seconds to 5 minutes to be learned depending on the stability of the flow. This process may take a full hour or longer for a 42-station system. Make sure you don't disturb the controller during the learning process. So once the controller has finished learning flow values for each station, you can go back in and review those values and edit them manually if you wish. Turn the dial to the Set Flow Monitoring position. Here, you will be able to scroll through all the stations and confirm that no stations show not learned. If you see a station with this message, that's because the station did not have a runtime prior to the learning process. Either manually enter the expected flow for this station or change the station to not monitored. To manually enter the station flow or change a station to not monitored, turn the dial away from Set Flow Monitoring, then press and hold the blue information button, and turn the dial back to Set Flow Monitoring. Here you will be able to see the learned flow value per station, and you'll also be able to edit the station's flow or change from not learned to not monitored. Station 4 shows not learned, so I can change that to not monitored. Another function you can change is the percentage limit at which the sensor reacts to the overflow. The default for this limit is 115%, which means the sensor will react to overflow conditions when the sensor detects flow values that are 15% over the normal value. We'll go ahead and change that to 125%. Many times, city water fluctuates so much that a limit of only 115% may result in false alarms. This limit can be changed by station. The other function you can change is the delay. The delay is the length of time the controller will wait before reacting to the overflow condition in order to prevent false alarms. The default is 1 minute, but you can increase or decrease this delay depending on how quickly your zone stabilizes their flow. Since air in the pipes due to drainage causes turbulence, you may have false alarms if the delay period is too short. If you decide to change the limit percentage or the delay period on all stations, you may want to make use of the copy and paste buttons. So the ACC controller also allows you to learn flow for just one zone, while leaving the rest of the learned flow values untouched for the other zones. This might be very helpful if, for example, you have an existing zone that you've added 3 or 4 sprinklers to, and you've changed that flow value, or you've increased it, so now you have to relearn that one zone. Or, for example, if you've added a whole nother zone to the system, and it has no learned flow value, you can learn just that zone while leaving the existing zones untouched. To learn flow for a single station, make sure the station has a runtime in a program. So we'll go to Set Station Runtimes and use the up arrow to go up to Station 5 and verify that he has 5 minutes shown. From there, we'll need to do the same process as before. Hold down the blue info, go to Set Flow Monitoring, and select Edit Learned Flow with the plus button. We'll use the up arrow to go to Station 5. And we see he has a flow value already, but we're going to zero that out down to not learned so that he's the only station that will go through the learn process. And now we're at not learned for station 5. Once the station is set to not learned, turn the dial back to the run position, and we'll use the copy learn button to initiate the flow process. You'll have to hit plus to verify that you want to start the process, and that way the controller will only learn flow for that one zone that was set to not learned. Once the controller is set up correctly with the learned flow values, it's ready for basic irrigation. As noted earlier, whenever a station is running, if you press and hold the information button, the display will show you a snapshot of the amount of gallons or liters per minute that zone is flowing. The same occurs when stations are set to overlap. When multiple stations are running simultaneously, the controller adds up the learned flow amounts for all the stations running, including their corresponding overflow limits, and it reacts to that new combined number. Whenever the controller detects an overflow, it's going to stop any station or station groups that were running for 1 minute and then restart each station individually to test their flows. Whenever the controller detects an overflow in a particular station or stations, the controller will stop all watering for 1 full minute. Then it will start each station that was running individually to test their flows. Each station will run for its delay period and then be tested. If the overflow remains, then it will shut down that station and move on to the next station. Stations that do not have an overflow condition will continue to operate normally. If there is a mainline rupture, all stations will continue to cause flow alarms. The controller will test each of them in turn and shut them down as they fail. So once all the stations have shut down, the normally closed master valve on the main line will also shut down because no more of the stations are calling for it to be open. At that point, you'll prevent any unnecessary water waste and runoff on the project. All of these alarm events will be logged in the alarm log. To track alarms, go to the data history dial position, use the down button to select alarm log, and hit plus to select. Here you can see the various alarms that the controller has detected. If you need more detailed information on how to set up the FlowSync flow sensor on the ACC controller, refer to the owner's manual or hunterindustries.com website, where you can find owner's manuals and other resources related to the ACC controller. Thanks for watching.